Hello and welcome to CheMentor, the chemistry mentor for Neet aspirants. In this video, I'm going to solve 7 chemistry questions with detailed explanation. So please keep watching till the last. Question number 1. When phenyl magnesium bromide is treated with carbon dioxide followed by acetic hydrolysis, it produces product P. 4 options are given as follows. Carbon dioxide is a linear molecule. It acts as an electrophile, so it is a Lewis acid. In carbon dioxide molecule, carbon is doubly bonded to oxygen. Since oxygen is more electronegative than carbon, oxygen acquires del negative charge and carbon acquires del positive charge. So in carbon dioxide molecule, carbon acts as electrophilic center. When you take phenyl magnesium bromide, the bond between carbon and magnesium is more of ionic character because of large difference in electronegativity of carbon and magnesium. Since carbon is more electronegative than magnesium, carbon acquires complete negative charge and magnesium acquires complete positive charge. So in phenyl magnesium bromide, phenyl carbanion can act as nucleophile. When phenyl magnesium bromide is reacted with carbon dioxide, the carbanion of phenyl magnesium bromide attacks the electrophilic carbon of carbon dioxide, giving rise to this intermediate. This intermediate, upon acidic hydrolysis, produces benzoic acid. So the correct option is C. Moving on to next question. Aniline is an activated system for electrophilic substitution reaction. The compound formed on heating aniline with acetic anhydride is 4 options are given. Activated system means it can increase electron density to benzene ring at ortho and para positions due to mesomeric or resonance effect. Aniline shows ortho-para directing nature to electrophile. In aniline, we have amino group. The nitrogen lone pair is delocalized, showing mesomeric effect. It can attack from ortho position, giving ortho substituted product, or the delocalization can take place in this way to produce the para substituted product. Amino group is electron donating group, so it is when present to any aromatic system, it is ortho-para directing to any electrophile. But as aniline, when reacts with acetic anhydride, different pattern of reaction is observed. That is, it undergoes nucleophilic substitution reaction. When aniline is treated with acetic anhydride, nitrogen lone pair attacks the carbonyl carbon of acetic anhydride. Then the bond pair is getting shifted towards this oxygen. It comes back again to form the pi bond. Then the carbon-oxygen bond is getting cleaved. So from here, acetate anion is moving out, giving rise to this intermediate. And in order to neutralize the positive charge on nitrogen, this hydrogen is picked up by the acetate anion which is going out from here, thus producing this product. So option D is the correct answer. Reaction of ethylene oxide with alkyl magnesium halide followed by hydrolysis leads to 4 options are as follows. Ethylene oxide is a cyclic ether. In ethylene oxide, we have carbon-oxygen bond, and this bond is polar bond. Oxygen being more electronegative acquires del negative charge and carbon acquires del positive charge. Now if you treat this with any nucleophile will attack this electrophilic carbon. ethylene oxide, when it is treated with Grignard reagent or alkyl magnesium halide. In alkyl magnesium halide, the alkyl part is nucleophilic in nature because of electronegativity difference. The R- will attack this electrophilic carbon of ethylene oxide, thus opening the ring. This bond will be getting clipped, and this electron pair will be taken up by this oxygen, giving rise to this intermediate. This can also be written in this way: R CH2 O MgX. So these upon acidic hydrolysis produces primary alcohol. So option C is the correct answer. Another question: Iodoform test is not given by. 4 options are given. Let's take the first 2 options. Okay, first let's talk about that Iodoform test will be given by those compounds in which you have methyl keto group, or you have this group. Why? Because this group upon oxidation will produce methyl keto group. Take first 2 options. In 2-pentanone we have methyl keto group, so this compound will show Iodoform test. In ethanol we have this group CH3 CHOH. So this group upon oxidation will produce methyl keto group, so ethanol also will show Iodoform test. Another 2 options, we have ethanol. In ethanol we have methyl keto group, so this also will show Iodoform test. But in case of 3-pentanone we do not have any methyl keto group. This is we do not have methyl keto group, so this compound will not show any Iodoform test. So option D is the correct answer. Moving on to another question: when metachlorobenzaldehyde is treated with 50% potassium hydroxide solution, the products formed is are. 4 options are given as follows. When any aldehyde is given with no alpha hydrogen and it is treated with 50% potassium hydroxide or concentrated potassium hydroxide, then undoubtedly it is Cannizzaro's reaction. We know that in Cannizzaro's reaction we treat aldehydes, and this aldehyde should not possess any alpha hydrogen. With 50% potassium hydroxide is treated and you get acid, salt and alcohol. This is the oxidized species, this is the reduced species. So Cannizzaro's reaction is nothing but it is an auto-oxidation reduction reaction. In the given question we have 2 molecules of aldehyde, that is nothing but metachlorobenzaldehyde. So one metachlorobenzaldehyde molecule will be oxidized to the corresponding acid salt, and another molecule of metachlorobenzaldehyde will be reduced to corresponding alcohol. So option C is the correct answer. Which of the following is more basic than aniline? 4 options are given as follows. Basicity is directly proportional to availability of donation of lone pair to any proton. It means if you have electron pair and this electron pair is more available for protonation, this system will be more basic. In case of aniline, the nitrogen lone pair is getting delocalized across the benzene ring. So here nitrogen lone pair is less available for protonation. So it is less basic. Let's compare between triphenylamine and diphenylamine. In triphenylamine, 3 phenyl groups are there, so the nitrogen lone pair can be delocalized over 3 phenyl groups. In this case, the nitrogen lone pair is delocalized over 2 phenyl groups. In this case, the nitrogen lone pair is least available for protonation, so it is least basic. Now if you compare between these two, this diphenylamine is more basic than triphenylamine. In case of para-nitroaniline, nitro group is electron withdrawing group. Electron withdrawing group decreases basicity. It is because the nitrogen lone pair is pulled towards nitro group, so it is less available for protonation, so it is less basic than aniline. In aniline, there is no nitro group, no pulling of the electron pair towards it, so aniline is more basic than para-nitroaniline. Take the case of benzylamine. The NH2 group is bonded to carbon, which is sp3 hybridized, and there is no possibility of delocalization of the nitrogen lone pair, so it is most basic. Which of the following is an example of nucleophilic substitution reaction? 4 options are given. The first option is nothing but is an Wurst reaction. Here an alkane is formed with double the number of carbon atoms present in alkyl halide, and this reaction proceeds via single electron transfer mechanism. Alkyl halide reacts with H2 to give RH and HX. So this is nothing but simple hydrogenation reaction. RX reacts with Mg to give RMgX. This is nothing but formation of Grignard reagent, simply insertion reaction. Mg is getting inserted between the bonds of R and X. The last option, Rx reacts with potassium hydroxide to give ROH and Kx. Here, potassium hydroxide first gets dissociated into K plus and OH minus. And OH minus, being electron rich, acts as a nucleophile. It attacks the alkyl group, which is del positive, because of presence of halogen, which is electron withdrawing, more electronegative. So this is electron deficient. So nucleophile attacks the electron deficient carbon of alkyl halide, thus substituting weaker nucleophile by OH. So this reaction is a nucleophilic substitution reaction because weaker nucleophile is getting substituted by strong nucleophile. So option D is the correct answer. Now you have learned solving some organic chemistry questions. If you have liked this video, please press the like button below, and don't forget to share this video. By subscribing my channel, you can receive all notifications of my latest videos. Keep watching CheMentor and keep learning. Thank you.